I'm privileged to invite Bradley Houk, Senior Engineering Advisor from ExxonMobil. He has more than 30 years of experience in the refining and chemicals industry. Most of his career has been focused in the control and optimization areas with activities ranging from regulatory controls to raw material evaluation. Since October 2017, he has been the program manager for ExxonMobil's Open Process Automation Program, which is leading the development of a standards-based, open, secure, and interoperable process control architecture. Prior to this, Brad led the global rollout of a new modeling and optimization platform and applications used for feedstock selection and production planning at ExxonMobil's refineries and basic chemical plants. Brad has a chemical engineering degree from Georgia Tech. Please welcome Brad. Thank you, Brad, for coming all the way.
When I hear that introduction, all I think about is how old I am. But I appreciate you guys being here this morning. Certainly appreciate the invitation from ARC to come and let ExxonMobil talk a little bit about our open process automation journey. One of the things I want to do this morning is challenge you to listen as I go through the case for action, why ExxonMobil got involved in this, what's happening in the industry. We are really seriously about trying to transform the industrial process control area. And it's something that we cannot do on our own. We need more end users. We need more suppliers to participate. So think of the next 30 minutes as an outreach session. Think of me as an evangelist coming and talking to you about what we're trying to do. And certainly open to your input, to your feedback. Do want to comment on the fact that ExxonMobil has released these slides, so they'll be made available by the ARC group following the meeting. So you don't need to, I mean, you can if you want to, but you don't have to take pictures. You don't have to, scribble a bunch of notes. The slides will be made available to you. So we've got 29 minutes left. What are we going to talk about? We've got an agenda. We'll talk with some background and an overview. We'll talk about the Open Process Automation Forum, and I apologize to the Open Group for using the abbreviations OPA, but we'll describe that a little bit later on what OPA is. We'll talk a little bit about how we develop a number of systems to do proof of concepts and prototypes. We'll talk about our collaboration partners, the testbed activities we're just kicking off, and I'll close with a summary and a challenge to the group about action and how we go forward. So from a background standpoint, I wanted to start with a little bit of history. So you can see from this, ExxonMobil's involved in this for a number of years. Back in 2010, ExxonMobil, when I talk ExxonMobil, I represent the downstream and chemicals side. So most of what I'll be talking about is specific to the refining and chemical side. It does apply to our upstream side, but most of the journey we're on is through the downstream. In 2010, we looked at our deployed DCSs and concluded we had a very large percentage of our kit was about to go into life all at one time. So Exxon has a long history of standardizing on one specific supplier. We did that for a number of reasons. It provided a lot of competitive advantage at the time. But what it ended up was that we were going to go into life with a huge bunch of our kit at the same time. And the leadership inside the business challenged the engineering organization to say, hey, can you guys go and do something different than just replace what we've got, replace it in kind, get new hardware, hardly any change in software, and continue to run for the next 30 years, and then do this again 30 years from now. So we started an R&D program, and I'll walk through some of our early observations. And coming out of that in 2014, we went through a bunch of internal and external sessions where we reviewed our findings, shared our vision, and I'll share that with the group this morning. That led to 2015, when we contracted with Lockheed Martin to define some requirements and really started working on the proof of concept. So you might ask, why Lockheed Martin? Lockheed Martin is not in the DCS area, but they're very much a system integrator. They've got a lot of expertise in software engineering and systems engineering. And so we selected them. We started that in 2015. 2016, we partnered with the Open Group. Would like to highlight the Open Group has a stand or a tabletop to my right, your left. So if you want some more information, we can talk about that later on today. We partnered with them and actually created the Open Process Automation Forum. So that was really to bring the industry along and help select standards for an open process automation system. In 2018, we completed the proof of concept and started our prototype. And then this year, we continued our prototype development and started our test bed. So key things to take away from this slide, I'll follow up more on proof of concept, the form, the prototype, and the test bed. So let's go on. Let's talk about our motivation. Back in 2010, as I mentioned, we were faced with a larger percentage of our kit going out of date, becoming obsolete. Our DCSs have a lot of advantages, but our study indicated they also have a number of challenges. And so you know what I'm talking about from a DCS scope of, does this work up here? Yeah, scope. We're talking about the basic control at the bottom. If you look at the classic Purdue model, that's level 1. And level 2 is supervisory control and operator station. DCS is typically inside ExxonMobil. We don't include our safety systems or our PLCs as part of the DCS. And what did we find? Well, we found our DCSs are primarily comprised of proprietary hardware, proprietary interfaces, and proprietary networks. That was driven by the desire to have maximum availability. The industry, as it developed, concluded that was the best way to do it. Well, it may have been true 20 or 30 years ago. Do not believe it's true today. Because of the nature of our DCSs, the suppliers tightly control what software can be put on your system. If you want to put more software, new software, up at level 4, you can do that. Maybe at level 3. But if you want to put new software or hardware down at level 2 or level 1, it better be provided by your current supplier. And that's a challenge. The other thing we've seen is security. For many of our historical systems, security was bolted on. It was added on. Many of our systems date from the 80s and 90s. At that time, everybody believed air gap. That was the answer to security. Well, that's not working so well for us today. And then, ultimately, a bottom challenge we have is very high cost and limited access to go new computing power or change the application platform. So that was some of our motivation that said, DCSs have served us well in the past, but there are some challenges today, and we'd like to overcome them. So as we reached into 2014, we began to develop a vision. So a vision, something we strive for, something we believe we can attain in the future, not something we have today. So what are the key characteristics of the vision that ExxonMobil developed for an open process control system? Well, we want the system to be based upon industry standard interfaces and networks, okay? We want the hardware to be interoperable. We want to be able to choose best-in-class components, both hardware and software components. And we want open software access. Let me clarify what I mean by open software access. We're not talking about open source software. We're talking about software that has open interfaces. We're specifically concerned about the interfaces that allow interoperability, interchangeability, and portability. So we're not asking suppliers to give away IP. We're not asking people to say, well, you've got to open source your DCS code. What we are asking people to do is use open interfaces to allow communication between various suppliers and various layers of software. We want security to be designed in from the beginning, both at the system level and the component level. And we want our software to be portable, okay? Today, we spend a very, very large amount of man-hours developing application software that turns out to be very unique to the particular system it's developed for. As we move from one system to another system, often even within the same supplier, that software is thrown away and redeveloped again and again as we move platforms. We want to stop that. We want to be able to have a software that continues beyond the use of the software, or the software continues beyond the use of the system. So when we first proposed this vision, a lot of people said, you guys are thinking the impossible. This has never happened. And so we gathered some data and looked outside our area to say, well, is it possible? Could we actually do this? What are some indications that might suggests we might be successful or suggests that there's really a lot of drivers for doing this. So some of these are summarized here. So when we looked outside other industries, we found that the avionics industry has actually done a very good job of creating open interfaces and interoperability between their platforms. In telecommunications, that has happened also. Some of the drivers we've seen, continued growth in computing power. We are running many of our plants today with computing power from the early 90s. Anybody here have a phone from the early 90s? How about a home PC from the early 90s? Every once in a while somebody will say, yeah, I do. You do. From the 70s, okay. I won't ask you to pay for our new DCS, so if you're still using your 70s computer. But why should DCSs be different from our classical IT infrastructure? Why can't we do rapid, low-cost investment and upgrades on our DCSs like we do on IT systems? The other things you see, lower-cost sensors. Well, lower-cost sensors are no longer lower cost when you bring them into your plant via your DCS. And then there's a number of other things happening in the industry, the industrial Internet of Things, big data, data analytics. We've got some sponsors here today that are active in those areas, cybersecurity, wireless, and cloud services, all contributing to the fact that the world is changing, and the closed proprietary nature that we have from 20 years ago is unacceptable. Okay, I need to pick up the pace. So this is an overview of our timeline. You can see the focus areas and participants. I want to walk you through so you understand the big picture, and then we'll come back and talk about each individual area in some more detail. So in 2016, we did our proof of concept. We followed that up with the prototype on a pilot unit. We'll talk about what that actually is and why we're doing it. We're now moving into our test bed, and that eventually we think will lead to field trials, industry field trials. And a very important partner we have going on is our collaboration partners. And we'll talk about who the collaboration partners is and what they're doing, but take away from this slide that they're being engaged in the test bed with the ultimate goal of doing independent field trials. And underpinning everything we do is the form, and the standards that are being produced. Okay? So let's talk a little bit about the Open Process Automation Forum. And as mentioned, this is coordinated by the Open Group. They have a table here today. So the Open Group is an organization focused on using standards, industry standards to drive the use of technology. They have a number of forums. Specifically for our activity, we've created the Open Process Automation Forum, and that forum is looking at selecting standards to be used to drive the transition in the industrial control space to open, interoperable industrial control platforms. Within the forum, we've got broad industry representation. We've got end users. We've got suppliers. We've got hardware and software component providers. We've got academia and system integrators. And I'll show you a list of who's in there. What has the forum done? Well, they started with developing a business guide, which was outlined the business case and what the future would look like from an eco-structure standpoint. They've moved on to selecting standards. We issued our first standard first part of this year called OPAS standard version 1. It's focused on interoperability. You can see the sections that are designed for the standard. Version 1 released covered parts, first 5 parts. We have version 2 and version 3 on the schedule being developed, which will provide a complete set of standards to create interoperable, interchangeable portability upon configuration and applications. So that's the forum. The forum is really doing a key role to identify the standards. It's impossible to have a standards-based architecture if you don't have standards, so it's critical the work the forum's doing. I want to share who's in the forum. This is not an eye exam, but I wanted you to get a feel for the number of members, about 80, 85 members up there. Specifically, I'd like to call out 2 that are local-based here. Reliance Industries is a member of the forum. They're active in the forum. And Tata Consulting. So we have some regional representative, and we'd like to have more. Okay. So let's talk about a proof of concept. As I mentioned, we worked with Lockheed Martin on this. What are we trying to do? Well, we wanted to demonstrate some of the key technical capabilities that an open interoperable system would have to address the questions about, is it possible to move from closed proprietary systems to open systems? And the way we were going to do that is we were going to create a system with components from multiple suppliers, okay? So as I mentioned, some people said, you're wasting your time, but we thought we'd give it a try. What did we want to do? We started with an approach of using existing standards where possible. So examples were OPC UA, DDS, and then 61499 from a communication standpoint. We started with laboratory components. Think laboratory components, think Raspberry Pis, okay? Certainly not something you want to run your CAT unit with, but something that was good for lab. We integrated in industrial components as they became available. We distributed the functions across the system, and I'll show you some of that. And the timeline was December 16 to April 18. So this is a picture of what the architecture looked like. Looked a little bit like our reference architecture. 10 different suppliers. This is only a simplified view. We did have zones and contours. We had multiple layers. People ask me, well, was it all flat architecture? No, it wasn't a flat network, so don't worry about that. You can see some of the different suppliers that were up there. And then I got one shot what the lab looked like. So this is our software development lab. Components were put up on the lab. Software was developed and tested on there. So what did we get out of the prototype? Assuming proof of concept. We demonstrated 4 key quality characteristics that we want out of our open system. Interoperability, interchangeability, configuration portability, and application portability. I want to spend just a minute talking to you about what those really mean. So from interoperability, we're talking about having components from different suppliers, exchange information, and have that information used by components from another supplier. So we did that. We connected. You can see what we connected, had that working. Interchangeability. We wanted to be able to take a function that was in one platform and replace that with a different component. We did that. We had a PID loop running in a Raspberry Pi, running in a 61499 environment. We replaced that with a similar application running in an Intel DCN. Configuration portability. So this is a little bit more challenging. What we had here is we had 2 versions of 1499, one from 4DAC, one from NXT Control. We created a control application in the 4DAC. We exported that configuration information, moved over, imported into the NXT system, and able to deploy that down to the NXT system without any change in configuration information. And finally, the one that we think is the most challenging was application portability, where we had a PID loop running on the DCN down at the south side of the bus, took that application, reassigned it, redeployed it to the higher level real-time advanced computing platform with no changes in code, just a recompile. So those are the 4 key quality attributes that we demonstrated on the proof of concept. So that led us to the prototype, which is where we are today. So the prototype is one of the many steps that are taking us from initial vision to final commercial deployment. Okay, along each stage, we're addressing key technical issues. Specifically for the prototype, what are we trying to do? We want to take an instance of an OPA system and actually put it on a pilot unit and run that pilot unit. So we want to be able to control the plant. We want to meet operator expectations. The proof of concept was strictly a lab experiment. It was not run any length of time. It did not have a console operator with it. For this activity, we're actually doing a mini DCS replacement project. The pilot plant today is under control by a legacy DCS. We're going to remove that legacy DCS, install the OPA system, run it for about 4 months, collect some experimental data, then transfer back to the legacy system. What we have found to date is the biggest challenge is creating what we're calling the systemness from a system that's made of heterogeneous components made from multiple suppliers. What the DCS suppliers do today is they do a really great job of integrating everything together, and when you get it, it all works. When you do your own integration, you've got to worry about things like security, alarms and messaging, engineering tools, and systems management. Not the high-tech stuff, but the stuff that your operator wants day in, day out. So let's talk a little bit about what the system looks like. I thought it might be useful. Some folks may not know what a pilot plant is. Within our industry, this is a small research unit. We use it for evaluating catalyst performance. So it is running at pressure, at temperature, okay? It has miniature versions of what you might expect in a plant. It has pumps, it has reactors, separators, and analyzers. Has typical process controls, temperature control, pressure control, feed control. I/O counts about 130 real I/O, 500 points. Total points, you can see 2 pictures, front end. These are actually the small pumps going into the reactor back here. This is the back end with the separation, hot and cold separators and a gas analysis system, okay? So what do we want to do with the OPA system? We want to demonstrate that we can duplicate the functionality that we have today in a legacy DCS and an open process control system. We want to have acceptable user feedback. So we actually have a console operator, okay? And if you're used to working with console operators, you know they can be very unforgiving, very true in their feedback. So we've got to meet their expectations. And then during this 4-month, we've got to demonstrate some stability and availability. So this is what the architecture looks like. You can see the components. In the interest of time, I won't go through that. But I do have another picture here. There we go. So this is the lab. Lockheed Martin's built up in Owego. We have 5 racks up there for testing and integration. At the end of the day, we will take components off of one of these racks, put it in a typical cabinet, move that cabinet down to our research lab, put it in, and control our pilot plant with it. Okay. So, collaboration partners. As I mentioned at the very beginning, ExxonMobil believes we cannot be successful doing this alone. We need to bring other people into play. So, we introduced the concept of collaboration partners. And what have we decided? What are we trying to do? We concluded that to be successful, you need both suppliers to bring components and you need users to buy components. Suppliers won't make components unless they believe people are going to buy them. So we said, what's one way that we can help accelerate the development and grow the ecostructure? And we decided that we would fund a test bed and then make that test bed available to our collaboration partners. Collaboration partners join ExxonMobil will use the test bed to evaluate components. Hopefully that'll provide the basis for the design and justification to do field trials, and then ultimately each collaboration partner will do their independent field trials. Show you who our collaboration partners are. Okay, we've got 6 of them today. We're currently in discussion with 3 other companies. I think you'll see an announcement in the next month or 2, at least with 1 other company. It'll grow the regional span of the collaboration partners, but we're happy to have those with us. And just want to close this slide on what are we doing. Well, as we have our collaboration partners, they'll add more system integrators to do their field trials. We'll use the standards. And an important thing is the collaboration partners are really looking at sharing the non-competitive information related to the OPA system performance. So, test bed, what are we going to do with it? We're using it to test components, whereas the prototype is really about running 4 months of stable operation in front of a console operator. This is about having a unit that you can use as an experimental unit. You can add and subtract components and actively use it for some R&D. Throughout our activities, as we head towards commercial readiness, what we're trying to do is reduce risk and provide a basis for commercial deployment. I want to just mention 3 of the key risks that we've identified that we're currently working on. One is just that creating a system from independent components may actually be a lot tougher than we think. Okay, this is first of a kind activity. The other 2 things continue to relate to reliability. One is, as we focus on interoperability, we may actually be at risk of losing some reliability or security. and that's unacceptable. We cannot have a drop in availability as we go to a heterogeneous system. And finally, in order to go to full deployment, you've got to have data that provides scalability. And how do you demonstrate scalability and reliability when you're currently doing individual field trials? Okay? So we're using the test bed to generate data, and we'll move along there. So test bed status, well, I mentioned earlier we're using Lockheed Martin as a system integrator. Lockheed Martin has been a really great partner for R&D, but they internally decided that they're not really in the DCS space. They've got a lot of skills in system engineering and system software, but they've decided not to go forward with the DCS work. So we did an evaluation earlier this year, late last year, to look at system integrators. We brought in a number of companies, interviewed them, talked to them, made some visits, and ultimately we selected Yokogawa to be our system integrator. It's very, very important that you understand the difference between a supplier and a system integrator. So we selected Yokogawa because of their deep understanding of the technical requirements for an OPA system and their willingness to function as an agnostic broker of components. So Yokogawa didn't get picked because they're going to sell us Yokogawa components. They got picked because they're going to do a software development for us. The open system will have components from many suppliers. We broke this activity into 3 stages. You can see that. The other thing we're doing is we will connect the test bed to a simulated plant. So right now we're looking at building a model probably of a simple 2-component distillation column, and we'll use that to drive the simulation. We hope to have the test bed operational by end year, and then we'll integrate new components, and we're hoping it's available to our collaboration partners early in 2020. When we look at an open process automation, what's going to make this successful is that using an open system provides you more value capture than a closed system. We're all on this for the money. Our companies, whether we're in the software side, whether we're in the hardware side, system integration, or in the user, it's about generating value for individual companies. So some key advantages that we think an open process automation will provide. One is support application reuse. If we're successful having systems that allow you to have application and configuration portability, it means you'll be able to upgrade your components and maintain your software. You'll be able to reuse your software. We also think having an open system will allow a lot more suppliers to come into the market, produce advanced applications, and get them deployed rapidly onto the system. Today's world, unless you're one of the top DCS suppliers, you don't have any hope of getting your software deployed down at level 2 or level 1. You're confined to a level 3 and above. And that limits the innovation that we believe you can see and achieve at level 1s and level 2. We think having an open system will support continuous innovation. No longer will you be doing these massive every 20 or 30 year upgrades. Okay? We'll be able to solve the system integration issue. We want a system that's safe and secure. We want to empower our workforce. Going back a little bit on system integration, one of the things we want is we want a system that allows us to do as needed or as justified component replacements. We want to have a system that we can replace an edge device, we can replace a computing device, we can replace a network component as we want to. We need we can develop a new application that needs more computing horsepower. We don't have to change out the whole system. We don't have to wait for our supplier to come out in 5 years with a computing system. We can do that near real time. And all of this, we think, will empower our workforce. Today, one of the key challenges we have is you hire really bright people coming out of university, and you sit them down and you say, your job is to program and maintain a 1990 or early 2000 computer system. And they look at you like, really? And then they leave, okay? We got to address that. There's no reason our control engineers can't be working on a system similar to what our IT folks have. In the last minute, let me just summarize where we are. We've got the proof of concept running or completed. We demonstrated 4 key quality attributes. Prototype development's underway. The forum is busy selecting standards. We're working with collaboration partners. There's an opportunity for system integrators as our collaboration partners move forward to their independent field trials. You'll see that as additional opportunities. And here's the takeaway: success factors. Critical mass of end users, suppliers that are bringing components to market, committed system integrators, and ultimately systems that increase value. I'm out of time. Okay? Thanks so much for your attention. Look forward to questions, and then feel free to contact me during today or tomorrow with additional questions.
Thank you very much, Bradley, for that great presentation on OPA. And I want to thank you very much for taking the time out to spend at this forum, and I think it's invaluable for both us and ARC as well as the audience. So thank you again.
Thank you.